I'm going to talk here about taking an equation in its standard or expanded form and then writing that equation in factored form and in vertex form, looking at all three forms of the equation. We can write an equation from a graph in any of those three forms, but that's actually not what I'm looking at doing in this video. We can talk about that separately. I'm looking at the graph over here just to check my work. I'm going to be looking at the equation and focus on taking that equation and changing its form. So I have an equation right here that is in standard or expanded form, and I want to get it in its factored and its vertex forms. So if I go in to think about factored form first, I'm going to use the product sum method. So I'm looking to find two numbers whose sum is the middle term, negative 12, and whose product is our last term, 35. So if I think about what goes into 35, I will think 5 and 7 go into 35. If both of those were negative, a negative 5 and a negative 7 are going to add up to negative 12. So those are the two numbers that we're going to want to have. So to write my equation in factored form, because the coefficient of x squared is just 1, I know that the only way to multiply to x squared is with x times x. So I can set my parentheses up with x minus 5 and x minus 7. Once I've finished the equation in factored form, I can confirm that it is the same equation as the original. So I've been able to rewrite from standard or expanded form now into factored form, same equation. Looks different, different representation. Okay, so that's the factored form of this equation. Now we're going to look at rewriting the same equation in vertex form. So I'm going to just copy and paste my original down here. I'm going to go from that original again now into vertex form. In vertex form, I'm looking to complete the square of the first two pieces. So I look at the coefficient of my b value, and in a perfect square, that would add to itself. So I know that there is some number, I'm going to call it k. Let me put this in a note real quick. There is some number k where 2 times k is that negative 12. That number is double something, right? And so the number k that I'm looking for, if I divide the 2 off from both sides, would be negative 6. To complete the square, I'm going to add k squared to both sides. Negative 6 squared is 36. Now, I said both sides. I'm going to undo that statement right here. And what I really want to do is add a 36 and then subtract a 36. So that way I haven't created a change right here. I've added 36 and also subtracted 36. No change has occurred in this function. Now I'm going to group this. So I look at the first 3 terms. This set of 3 terms should be a perfect square. Okay, factor that part now. So when I factor that, it should be the case that this number k is the number that I factor into. If the sum is negative 12 and the product is negative 36, 2 negative 6's should do that. Negative 6 plus negative 6 is 12, and negative 6 times negative 6 is positive 36. So I can factor this portion into x minus 6 times x minus 6. So I'm going to go ahead and do that. X minus 6 times x minus 6. So that takes the place of that trinomial piece. Okay. And of course, if you have x minus 6 times itself, that's really the same thing as x minus 6 squared, right? So the last part right here, I had a negative 36 plus 35. Those are like terms that can combine to negative 1. So this is now that same equation rewritten in its vertex form, and you can see that it graphs right on top of the original equation. It's in its vertex form. So that same equation is written here in standard form, factored form, and vertex form. Okay, I'm going to do this again. If you want to see another example, in the next example here, I have an equation that has been represented in factored form. And I can take it from its factored form into both standard and vertex form. If I wanted to get into standard form, I would want to multiply this out. X times x is x squared. X times negative 9, negative 9x. Then 7 times x plus 7x. And then 7 times negative 9 would be negative 63. Just want to combine these two like terms right here. The negative 9x plus the 7x will give us negative 2x. Again, this is the standard form, and if I check, I can see that it graphs right on top of the other graph. They're right on top of each other, so they are identical. All right, so that's my equation in standard form. If I want vertex form, I do need to start vertex form from standard form. I can't start it directly from factored form. So I'll take my factored form and write it in vertex form first, and then we will get the vertex form. Okay, so I'm going to go through that same argument where the middle number needs to be twice something. So 2 times k is equal to negative 2. The middle number is twice something. So that means that the k value that I'm looking for, if I divide both sides by 2, must be negative 1. And the k squared value must be positive 1. So I'm going to grab this equation, and I'm going to add in k squared and subtract off k squared so that I can make these 3 terms part of a group. The first 3 terms should be part of a group that is factorable. Okay, and they should factor into x plus k squared. So k should be the number that when you multiply it by itself gives you the product of 1, and when you add it to itself gives you the sum of negative 2. So negative 1 plus negative 1 is 2, negative 1 times negative 1 is 1. So k is the number that will allow me to factor this, and I need it twice. So this part of it factors as x minus 1 times x minus 1. So that part is x minus 1 times x minus 1. Oops. There we go. And so I know that if I multiply x minus 1 times itself, that is x minus 1 squared. Now I simplify over here. These are like terms. Negative 1 minus 63 is a negative 64. Once again, I can observe that I have the correct equation because the vertex form equation is lining up directly over top of the standard form and factored form equations. Okay. So it took something that wasn't factored form and found the other 2 forms, found the standard expanded form, and we found the vertex form. If you've had enough, then we can stop here, or we can look at one more example where the equation starts in vertex form and we can find the other 2 forms. Now, I'll notice in this one, it starts in vertex form, and I do have an a value. In vertex form, you can have your a plus or minus h plus or minus k. The a values in all of the other ones was 1. There was no number right here. In Math 139 College Algebra class, we're not going to ask you to put something into a vertex form if the a value is not 1. You would do that in maybe a pre-calculus class or a class after this, but it's not part of what we're practicing right now. We're introducing this topic. We're not going to perfect it. We're going to look at ones where the a value is 1 and take those into vertex form. But if I'm already in vertex form, that doesn't matter. If I'm already in vertex form, I can expand this even if the a value is not 1. So if that's the case here, I'm already in vertex form, I can expand this. I know that having x minus 4 squared means to have x minus 4 times x minus 4. So I'm going to write that out. And then we're going to expand this part. We're going to go for our expanded form first here. Okay. So when I multiply the x minus 4 times x minus 4, that'll give me, let's see, 2 times, x times x is x squared. Then x times negative 4 is minus 4x. Then negative 4 times x is minus 4x. Then negative 4 times negative 4 is plus 16. Okay, so I've written it down, I've expanded that out, and now I'm going to distribute this too. I'm just going to get rid of this line. On paper, you would keep this line just to keep my decimals log here clean. I will get rid of it. I want to distribute this 2. So when I distribute this 2 into the parentheses, that'll be 2 times x squared. 2 times 4 is 8. 2 times 4 is 8. 2 times 16 is 32. And then that finishes the parenthesis. So I stop distributing the 2. Okay. Combining like terms, we have negative 8x and negative 8x. That's going to be negative 16x. And I also have this positive 32 minus 8. That's going to become a positive 24. So they're both red, but if I click and unclick one of them, you should be able to see that they are graphing on top of each other. So this would be the simplified version in expanded or standard form of the original equation. I always get expanded or standard form first, no matter where I start. If I start there, I can go into either factored form or vertex form. I can go to either of those from standard form. If I start in either factored or vertex, I go to standard, and then I can get the other one from there. I can get either of them from standard. Okay, so we're going to attempt now to get factored form. The first thing to notice in factored form is that all three of these coefficients, the 2, the negative 16, the 24, can all be divided by 2. So we are going to factor that 2 out. When I factor that 2 out, I'll have 1x squared left. I'll have 16 divided by 2 is 8, and I'll have 24 divided by 2 is 12. So that will have that 2 now factored out. Then we're going to look for a pair of numbers whose sum is negative 8 and whose product is 12. So those two numbers, let's see, what goes into 12 might be 2 and 6. If they're both negative, a negative 2 and a negative 6 are going to add up to negative 8, and they will multiply to a positive 12. Okay, so in factored form, I will have that 2 out front still. We're going to have x times x to make x squared, and then we'll want x minus 2 and x minus 6 to get that factored. So this part right here is factored into the x plus 2 times the x minus 6. Okay, that line is not fully factored. It was part of my work. I'm going to clear it for a moment so I can see the three forms of this equation. We have our original in vertex form, we have our standard form, and we have our factored form. And this line right here in factored form, we should be able to observe is the same curve as we saw for the others. So we're checking graphically that we have not done any harm by rewriting the equation. All three of those still present the same graph. Okay, so hope that helps. You can take any one of the forms in their equation to get any of the other forms.